Hello guys, so welcome to our channel, Round Basic. So this time, we will learn how to solve your domain in range of rational functions. So example on the board, we have here your rational function f of x equals to 3 minus x over x plus 1. So before that, let us go back to the definition of your domain in range. So when we say domain, these are the values of x, or the values that your x can take. So it is your input and it is your independent variable, while your range are the values that your variable y can take. Okay, so to be simple, your domain are the x values and the range are the y values of your rational functions. Okay, so let us proceed to your f of x equals to 3 minus x over x plus 1. Okay, so before we solve your domain, let us simplify your f of x into the form of this one. We have f of x equal to y. Or let us put your f of x in the form y equals to 3 over x. 3 minus x, I mean, over x plus 1. Okay? Then, when you are solving for your domain, okay, when you are solving for your domain, you will have to focus on the denominator for us to be more, for us to solve it more easily, and how to make it, or how to make your solution more simple. So just look at your denominator. So your denominator is x plus 1, and then equate your denominator into 0. So we have x plus 1 equals 0, and then solve for x. So we have x equal to negative 1. So this time we will use x equal to negative 1. And this means that when x is equal to negative 1, your denominator, this one, will become 0. And then, when your denominator becomes 0, therefore, your rational function becomes undefined. So, if you have this one, example, your numerator is denoted by r of x as a rational function, and then your numerator is 0, it will become undefined. Okay? So why did we solve your denominator and equate it to 0? That we all know that it will be undefined. Okay, so this is how to put your domain. So we have this type of notation. So domain for x is not equal to negative 1. Okay, domain is x not equal to negative 1, because at negative 1, this one, at negative 1, your denominator becomes 0, and when your denominator becomes 0, it will be, or the rational function will become undefined. So are we clear? So that is just the reason why did we solve this one. But the correct answer for your domain is this one. X is not equal to negative 1. So it means that all the values of x, so this is very important, all the values of your real number are accepted as your domain. Okay? All real numbers except negative 1. Because at -1, your rational function, this one, will become undefined. Okay, so there is another way of putting your domain. So using your set builder notation. So using your set builder notation, we can have this one. Brace x is an element E of real number such that x is not equal to -1. Then brace. Okay? Then we have the last or another way of writing your solution. So we have this basic notation in writing your domain. Then we have your set builder notation. So we have your set builder notation. Okay? And last is your interval notation. So I will write it. Interval notation. Okay. So let us have a visual presentation of your. So we have x equal to -1 in here. Okay, x equal to -1. So if you will try to look the graph will look like this. Okay? Something like that. So the graph will not pass at x equal to -1. Okay, so let us focus on this line, your x-axis. So it means from -1 until -infinity. And from -1 here, -1 until +infinity are the values of your x or your domain. So it means all values of your x that can be seen in your x-axis are accepted except on this value on -1. So it will be discussed on your next video about this broken line. Okay, this line is called as asymptote. So your graph cannot pass at this line or at the value of -1 because again, when your x is -1, your rational function will become undefined. Okay, so for interval notation, we have this notation. Okay, so we have -1, -1 until -infinity. Until -infinity. Then from -1 into +infinity. So this letter U center implies union. It means from -1 to -infinity, union from -1 to +infinity. So we will use parentheses because -1 is not part of the solution, as well as parentheses on your infinity because we cannot determine where infinity will end or exactly end. Okay, so I guess we are clear on the first example. So that is how to solve for the domain of the rational function for number 1 here. Now let us solve for your range. Solving for range, we need to simplify your given rational function. So assuming that your rational function y equals to 3 minus x over x plus 1 is already in simplified form. So the next step will be this step. We will cross multiply x to the other side of your equation. So we have y times the quantity of x plus 1 equals to 3 minus x. Okay? Then let us distribute. Y times x is xy, or you can write it as yx. But we should write it always in alphabetical form or alphabetical order. So y times 1 is positive y. Copy equals to 3 minus x. Then combine all the terms with x. So we have x, y, plus x. So where did we get this plus x? So we have to plus x. Okay, so I will write it for those who are not knowledgeable in this. So we have x, y from the xy on the top. Then we have break down 3. Then we have 2 plus x. Because we added x in here, we will add x in here. So we have plus x. So that is the addition property of equality. Some of us are solving it by transposition. So again, transposition is not an operation for equations, but most of us are using it. Then put y on the other side of your equation. So we have minus y minus y. So y will be eliminated on this side, and we have minus y on the other side. Okay? But it is very basic, and I know that you already knew it. So we have this one. So factoring the common. So the common between x, y, and x, of course, is x. So following the common, so we have plus 1. So if you have to check this, if you are correct, just multiply it again, x times y, so you will come back at xy. X times 1 is x, so we are correct. Then we have 3 minus y. Okay? Then we have to isolate x on the other side of your equation. Okay, so we have x times y plus 1, copying, equals to 3 minus y. Divide both sides by quantity of y plus 1. So we divided y plus 1 on the other side. So we must divide this side by y plus 1. So we have the remaining x equals to 3 minus y over y plus 1. Okay? So we will have to use this form. So in solving your range, the first procedure is isolating your x variable to the other side of your equation. And then you will know that you are on the right track when your denominator is in the y variable. So again, you have to multiply your denominator to y on the other side, then simplify, then isolate x on the other side. Okay? Then let us focus on your denominator. So the denominator is y plus 1 equals 0. Then we will have to use the same concept that when your denominator is 0, your rational function will become undefined. So we will let us try to solve or find for the value of y which your denominator becomes 0 or your rational function becomes undefined. So y is equal to negative 1. Okay? Negative 1. But your range, again, just like your domain, just like this one, we have solved x, but your domain is x equal to y. Of course, your range will be y not equal to negative 1. Or in set builder notation, we can write it as y is an element of real number such that y is not equal to 1 or negative 1, I mean. Then brace. For your set or interval notation, negative 1 is your until, of course, just like we have positive infinity and negative infinity. So you will ask me why did I write positive and I did not write positive here. So if I will, the positive, they are the same. Either I put the positive sign or not, they are the same. So when a number or value don't have any sign, therefore that number is positive. So we have solved the range and the domain of your rational function. So we have three ways to write your domain and range. You have to choose one. It's up to you. Okay? Where you are feeling comfortable with either this one, or this one. So the same with your domain, you have three ways to write your range. Okay, so I will give you a hint of the graph of this function. So this function again will pass at -1 as just like this one. Then at -1, example, -1, -2, then we have -3, so -2. At -1, your function again will not pass at -1. Okay? So I will discuss it on the other video. So these lines are called the asymptotes of your rational functions. Okay? So let us have another example for us to solve it more. We have here g of x equals to x squared minus 3x plus 2 over x squared minus 4. So we are on another level of your function in solving your domain range. So before we start solving it, let us simplify your f of x, or sorry, our given is g of x. So we have g of x equal to y. Then we have y equals to x squared, copying 3x plus 2 over x squared minus 4. So before we can solve for the domain range, let us first simplify your given function. So we are on a quadratic rational function, so we can assume that we can factor your numerator and denominator and then simplify your function. So we have x squared minus 3x plus 2. By factoring, we can get x minus 2 times x minus 1. By FOIL method or multiplying these two binomial, you can come back at x squared minus 3x plus 2. Then the factors of x squared minus 4 as a difference of two squares. So we have x plus 2 and x minus 2. Okay? Or it can be x minus 2, x plus 2. Then, looking at the common factors, we can say that y is equal to, the remaining factor is x minus 1 and x plus 2. Okay? So on another video, I have discussed on how to get the factors of the two expression. We have your x squared minus 3x plus 2. So how did we get to this factor, and x squared minus 4, and how did we get to this? So we will be using this rational function in solving your domain and range. So this is the simplified form of the given function. Okay? So solving for the domain. Again, in solving your domain, we have to focus on the denominator. So the denominator is x plus 2, then equate to 0. Then solve for x, so we have x equal to -2. Then putting your domain, so your domain is x not equal to -2. Very easy. Then using set builder notation, we can write it as x is an element of real number such that x is not equal to -2. Okay? By set builder notation, we can have this one. And by interval notation, we can have this -2, positive infinity, negative infinity, parentheses, parentheses, union. Very easy. Okay? Let us solve for the range. Range. So before we can solve for the range, let us solve and simplify your function and then isolate x on the other side of your equation. So we have this 1, y equals to x minus 1 over x plus 2, cross multiply. So we have y times x plus 2. Copy your numerator, x minus 1, multiplying by distribution property. So we have xy, then y times 2. So we have 2y equals to x minus 1, copying. Okay, are we clear? Then, combine all the terms with the variable x. So, we have to transfer x on the other side. It will become negative x. Bring down negative 1. Then, we have to transfer positive 2y on the other side. So, it will become negative 2y. Okay? Then, factoring the common between x, y, and x is x, of course. So x, the remaining will be y, and minus 1. Then copying negative minus 2y. Okay? Then to isolate x, we have to divide your equation by y minus 1, y minus 1. Cancel. Or y minus 1 divided by y minus 1 is 1. So the remaining is x, this one. Then, on the other side of your equation, we have, so x will become negative 1 minus 2y over y minus 1. So we will again focus on the denominator. The denominator is y equal to 1, equate to 0, then solve for y. Then we have y is equal to positive 2. Writing the range, we have range where y is not equal to positive 1. Using the set builder notation, we can write it as y is an element of real number such that y is not equal to 1. Brace. Then, again, using your interval notation, so we have 1, 1, negative infinity, positive infinity, comma, comma. So, very easy. Okay, let's proceed to the last example. Okay, so we have this example, h of x equals to x minus 3 over x squared minus 9. So let us solve this rational function as fast as we can. So we have h of x is equal to y. Therefore, we have y is equal to x minus 3 over x squared minus 9. Then, you can see your denominator is in quadratic degree. So we can assume, and if you will try to look, that it is difference of two squares, x squared minus 9. So the first term is a perfect square as well as the second term. So we can put your denominator in factored form. So the factor of x squared is x times x. The factor of 9 is 3 times 3. Then negative, so we have to multiply negative and positive. Okay? Then if you can see the common, so we have x minus 3 and x minus 3. Therefore, the rational function in simplified form is 1 over x plus 3. So someone will be asking, where did we get this 1? So 1 is the factor of x minus 3 in there. So it is understood whether you write 1 or not, it is understood that there is a factor 1 in that. So I have discussed it on the other video. Okay, let us proceed using this function. Let us solve your domain. So again, solving your domain, you will have to focus on the denominator. So looking at the denominator, we have x plus 3. Equate it to 0 and solve for x, so you have negative 3. Writing your domain is x not equal to negative 3. Using the set builder notation, x is an element of real number such that x is not equal to negative 3. Then, writing it again on the interval notation, we have this two parentheses, union, negative infinity, then negative 3, and positive infinity. Okay? So easy. Let us solve for the range. So solving the range, before we proceed with your denominator, let us simplify y equals to 1 over x plus 3. Then cross multiplying y times x plus 3 equal to 1. Okay? Following? Then we have x or y times x by distribution property. So you have xy. Then y times 3 is 3y equals to 1. Okay? You can see there, isolating x. So the remaining, because we don't have any variable to be combined because x don't have any like terms in there. So you have x, y, this one, then transferring your 3y by subtraction property of equality. So we on this form, then isolating your x by dividing it to y. So x will be equal to 1 over 3y over y. Okay? So I will write it again in there. X is equal to 1 over 3y over y. So looking at your denominator, so your denominator is y. Equate it to 0, so therefore we are on your range. So range is y not equal to 0. Builder notation, y is an element of real number such that y is not equal to 0. Then interval notation, union at the middle, letter u. So we have 0, 0, negative infinity, and positive infinity. So positive infinity, the symbol of infinity is horizontal number 8. Okay? So I guess we are clear on solving the domain range of your rational function. I hope that you have learned something from this video. Thank you so much for watching. Please subscribe.